Alright, we're going to talk about section 4.5, statistics, conditional probability, and independence. To start out with 4.5, we're going to talk about the general multiplication rule. And that is displayed right there in front of you, with probability of A and B equals the probability of A times the probability of B given A. Okay? So with that, we're going to do a little tree diagram here and show how that plays out. So there's an example right here we did in our big ideas, in which case you're taking the probability of A and then moving forward with the actual probabilities, and you'll see there at the end that to actually get the values for the ending result, we would simply take the equation I just mentioned for probability of A and B would equal the probability of A times the probability of B given A. Alright, so it looks a little wild right there up front, but we're going to go through an example and explain that. Okay, so we got a card game here. We're going to, can you get a pair of aces or a pair of kings? So this is a game that I normally like to play in class here when we can be able to do face-to-face. So rules of the game. Start with 5 cards total. You're going to have 2 aces and 3 kings. The player chooses their first card and records the results, and then chooses their second card and records the results. The player wins if they get a pair of aces or a pair of kings. Okay, so if you get a pair of aces or a pair of kings, you would win. So let's try to use a tree diagram to calculate the theoretical probability. So we're going to fill in the blank boxes the correct probabilities. So we're going to do a tree diagram just like this and find out what the probabilities are that we have. Okay? So again, we got to think about this too, right? How many cards do we have in the beginning? And so we have 2 aces and 3 kings. So we have 5 cards total. All right? And out of those 5 cards, again, we have 2 that are an ace and 3 that are a king. So we'll say this. So let's go with the way it's written out here. It shows that we have our first card is an ace up top. So in other words, that's the probability of drawing an ace card. So if we just have 2 ace cards, what is the probability of drawing out of 5? We're going to have 2/5. So 2 over 5. We have a 2 out of 5 chance of drawing an ace card, right? So now if we go down here for the king, well, there's 3 kings in the stack of 5, so we have a 3 out of 5 chance. Okay, so once we've drawn, let's go back up here and just talk about our ace card, okay? So the first card was an ace. So now, how many cards do we have total in the deck? We've already taken 1 out, well, we just have 4, right? So we know it's going to be out of 4. And then it's showing that this top line here in our tree is going to go, the second card is an ace. So if we've already drawn 1 ace out of there, then we just have 1 ace left in the stack, and there's only 4 cards. So we have a 1 out of 4 chance to draw that second card as an ace. Now with this, with dealing with the king, right, there's still 3 kings in that stack of cards because we've only drawn out 1 ace card. So we have a probability of 3 out of 4 that are king, because again, there's a stack of 4 cards, so we've only drawn 1 ace out, and we have 4 cards total, and in those 4 cards there are 3 kings and 1 ace. So if we had a probability of drawing that second card as an ace, it'd be 1 over 4. If we would draw the second card as a king, it'd be 3 over 4. Let's go down here with the kings. So again, we drew our first card as a king. So now we have, again, as before, there's 1 card gone, so we still have 4 cards in the stack. And now it's saying the second card is an ace. Well, if we're to do that, we also have 2 aces in the stack of 4. So we have 2 aces and 2 kings. So you have a 2 out of 4 chance of drawing the second card as an ace. And again, like I said, we still had 2 kings in that 4, just like we had 2 aces. So if we were to draw a king for our second card, that would still be a 2 out of 4 chance. Now the general multiplication rule comes into play here, okay? Again, with the general multiplication rule, we're taking a probability of A and B, and that's going to equal the probability of A times the probability of B given A has occurred. So in this case, we're taking our probability of A, so probability of getting an ace card was 2/5, and the probability of getting our second ace card, given that one ace card has been drawn, is 1/4, so multiply times 1/4, and you should get 2/20. So that's our probability of getting two aces, all right? So now, our probability of drawing an ace card again was 2/5, and times, in this case, we're talking about drawing second card as a king. Well, there's a 3 out of 4 chance of drawing a king given that we've drawn an ace card already. So 3/4. So we should get 6/20. Okay, so now with our kings, we had a 3 out of 5 chance of drawing the first card as a king. So that was our probability. 3 out of 5 for first card as a king. That's been multiplied by, for this one, it says the second card was an ace. Well, we had a 2 out of 4 chance to draw that, given that the first card was a king. So we're left with 6/20. And for this one, we have the first card as a king was 3 out of 5. So 3/5. And then multiplied times the probability of drawing the second card as a king given the first card was drawn as a king. That's 2/4. And again, we're left with 6/20. With this, it said the winners, right, were either a pair of aces or a pair of kings. So with this, our winners are that probability and that probability, right? Because 2 aces are 2 kings. The ones in the middle is an ace and a king. And the other one in the middle is a king and an ace. Those are probabilities for winners. So let's see what we got to do next. So let's find the theoretical probability of winning the game then. If we know those are 2 probabilities, for that, we would take these probabilities and just need to add them together. So we're going to take 2/20, because that's for 2 aces, and we're going to add the probability of getting 2 kings, which was 6/20. So 2 kings. And with that, we can simply see that that is going to be 8/20. And when that's put in the calculator, you get a decimal value. You get 0.40. And that is 40%. So in this game, there was a theoretical probability of winning the game was 40%. So you had a 40% chance of winning the game theoretically. So what is the probability that the first card was a king given the person won the game? So first card a king given the person won the game. Okay, so with this it says probability that first was a king. So we'll say first is a king, given that the person won. So the person won. Well, from the equations that we've dealt with on this, we should know that we need to talk about up top is the probability of A and B. So probability of first king and winning. So probability of first king and winning was 6/20. So I have 6/20. That's divided by the probability of the given. Well, the given was the person won. Well, to win, we know that value, we just calculated, right? The probability to win this game was 0.4 or 8/20, however you'd like to work it out. We'll just put the fraction, since we've got fractions going on. We'll say over 20. And that gives us 6 over 8. Okay? And that should give us 0.75. So a 75%. So you have a 75% chance of winning if the first card is a king. So again, when you're presented with a problem such as this, and dealing with a tree diagram is the easiest way to draw it out, okay? When you have the different options there based off, let's say your first choice and then what happens from there. So the tree diagram definitely lets you draw out the probabilities and then easier to calculate the ending results, okay? And then you can find out the probability of is to win in whichever case may be, or to lose. And allows the follow-up question, shall we say, to be easily answered from there once you're able to make this tree diagram. So the big thing, take away understanding of this formula, and that it is going down the tree diagram to calculate these values, okay? And moving forward with adding up the probabilities if there's multiple chances of winning, multiple chances of losing, if that needs to be the case. All right, guys, hope you learned a little bit of something dealing with our conditional probabilities and independence, and I'll see you next time.